today. Beat you dubs. Alright, so the distance from A to B, or the length of line segment AB is denoted AB with a line over. So I just want to clarify that I made an error, made an oopsie on that first day. I have not done geometry in a while, and I forgot that without the line over, it actually tells you the distance of that segment. So it specifically is not referring to that segment, but to the distance of the segment. So on the early stuff, I'm not going to worry about that, but here, now we're going to start differentiating between the two. It's going to become very clear today. Okay? So, yep, this one, the distance, right? So if I wanted to talk about the length, I would say, okay, AB is equal to 24.3 centimeters. Done. Okay, congruent. And remember what the words are in this? It means same
side, and I keep different things.
That's came in my head.
Same length, so same size.
Shape.
And shape. We say size because not everything has just length, right? It has like height and width and stuff too. No. Size. So if we wanted to make a statement about this, we could say that the lengths are equal, right? By saying, okay, so the length AB is equal to the length CD. That's literally it. However, if I wanted to use congruence, I wanted to say that not only are they equal length, but they're like the same format and everything, which is pretty, with lines you don't really have any other options, but with other shapes you have angles and stuff. So we're just starting at the bottom. We'll go up. So segments are congruent. You would say that line segment AB, more specifically talking about that exact one, is congruent. So this is the symbol for congruent. It's an equal sign with a tilde above it, like in Spanish class. And like this is called a tilde, like on your.
Matilda. I thought you said something in French. I was like.
No. So an equal sign, and then it has a tilde on it, like on the top of like an N for jalapeno. But it's not like equal or something. It's just equal or congruent. And then CD, line segment CD. So the statements are just a little different. You can't use equal signs with segments, and you can't use congruent symbols with lengths. These are different like bodies of stuff in geometry. Okay. For example, on this figure here, figure A, I'm just going to go ahead and give myself some definition. This is for figure A, B, and C. On figure A, what equality statement could I make?
PQR.
PQ equals QR.
Yeah, PQ equals QR. The length of PQ is equal to the length of QR. Okay? So tick marks denote equality, right, or congruence. You have the right language. Tick marks is what you call those. Okay? And so then our congruent statement would be the same, except we're specifically talking about that line segment, not just that length, is congruent to line segment QR.
So if it's a line segment, there's that
Line.
thing.
Jalapeno thing, yeah. The congruent symbol. Okay. So lengths are equal. Objects are congruent. That makes sense. All right. How about B? Who's got a congruent statement for me?
Oh, wait, first. Can we say everyone, the whole one, or just say one thing?
You can do them all if you want.
Alright. KL is equal to NP. NP.
Okay.
Then LM is equal to NN.
Okay. Anything else? There's a couple more. 2 more. Or one more set. Actually, there's 2 more sets. You see it?
Just should do KB equal to U.
No, because that's the same one. But you're on the right track.
Just switch it around.
No, that doesn't work. That means the same thing. What you got?
L. N. I don't know.
No? Still
LK and LM.
LK and LM? No, those aren't equal because they have different number of tick marks.
KM and MP.
Yep. KM and MP. And there's one more set.
K.
Well, you see it?
I don't know. P. No. I feel like I'm gonna get it wrong.
Just
But
say
is it P L and
PL is correct. PL and
DK.
no?
no. K. I need some help from there.
V?
KN.
KN. This is where the whole like using your fingers thing goes, right? So this one is the same distance as this one, right? Not that like fingers are used for measuring, but like it's a good tool to help you out. Good. Alright, so then we would just transfer all these to congruent statements, correct? So we've done thinking, now we're just going to rewrite these as congruent statements. So line segment KL is congruent to line segment NP. Line segment LM is congruent to line segment MN. Line segment KM congruent to line segment MP. And line segment PL is congruent to line segment KN. Sweet. Okay. Last one. Who's got some of these? Yeah?
X, Y, Z, W.
X, Y, so you can make a triple statement, right? X, Y is equal to Y, Z
Yeah.
is equal to Z, W. Okay? What other statements could you make? I see one more. Paula?
Y, W
Oops, sorry. Didn't want that.
equals W Z X X Z.
XZ. Good. So then we would just make this into a congruent statement. So you can have a triple again here. That's fine. Sweet. Questions about this first page? Alright, moving on. Alright, a postulate. A postulate is a statement that is assumed to be true without proof. A theorem is a true statement that can be proven. So we have our first postulate here. What's going to happen on your summatives? I will give you a sheet of paper with all of the postulates and theorems and formulas that we've used so far, and you can use that on your, it'll be like something you have on the paper, on the table. You can use it and then you give back to me and I'll use it for the next class. Does that make sense? But it will grow like increasingly more and more and more until the end of the year where it's like a page and a half. Okay? So you won't have to have all of that with you that day. It'll be all together in a row. Does that make sense? Like easy reading. Whatever. Okay. Segment addition postulate. So here's our first one. If a segment is divided into parts, the sum of the parts is equal to the whole. So if I add the length AB plus the length BC, I get the length of AC. Simple, easy. All right, add it together, you get the whole thing. Seems simple, but then we're gonna make it harder. Ready?
Oh, yeah.
Okay, so for example here, if I know some of these, what you're going to do is just going to fill them in here. So AB is 14. I don't know BC, but I do know AC, and that's 36. So then what's BC?
36 minus 14.
Which is?
22.
So BC is equal to 22. Yep, now it's stuck in the middle there. Alright, so who would like to talk through setting this one up? Anyone want to just set it up? I'm not going to make you solve it, I just want you to set it up. What you got? Alright, I got it then. So I'm just going to go ahead and put my guide up here again. So AB is x plus BC is 2x equals AC, which is 18. So then I'm just solving an equation here. No biggie. X and 2x is 3x. 3 times 6 is 18, so x is equal to 6. What? That is the whole problem. Oh, yep, and then I need to find the length.
Yeah, then you have to, yeah.
Okay, so then the length AB is 6. We don't seem to have any units here, so it's just 6 for right now. And BC is 12. Good. How about the next one? Anybody want to set it up? Okay, so our guide is there. So then what's my next line going to say?
2x plus 3 plus 3x minus 1 equals 27.
Yeah, it's like that doesn't fit, but it does. Okay, so then we're just combining. So what's my coefficient on my x? 5. And then I've got 3 take away 1, so 2. So take away 2 from both sides, 5x equals 25. X is, yep. So then, let's see, AB and BC we don't know. So AB is this part right here, right? So 2 times 5 is 10, plus 3 is 13. I could even make that marking here so I remember to do that. Right? And 3 times 5 minus 1. So 15 take away 1, 14. And then you can double check, right? Does 14 plus 13 equal 27? Yep, sweet. Questions about this? Yes, ma'am.
So if it's like AB, never mind, I got it now.
Okay. It's just saying add the parts together to get the whole, and you just gotta solve the thing. For me, like, the biggest thing is having this at the top each time so that I, like, reinforce that for myself and I put it in the right spot. It's like it takes all the thinking away once I have that guide there. You know? I like to eliminate all thinking if I can. I'm a lazy mathematician. Tricks, stuff, that's what I like. Alright.